Hey guys, Brendan from TAT here. Today I'm just going to talk about a couple of diagnostic programs that we've got on the site and show you how to use them. So we all know that we like tech here at TAT, but the trusty old vacuum gauge is still as useful as it ever was. So there's a couple of programs on the TAT website that relate to the vacuum gauge that I want to walk you through.
So I'm logged into the TAT website as a member on www.tat.net.au. Now, one of the many features that we have on the website are these diagnostic programs. So if we go into them, specifically today, going down the list of all of these programs we got here, one of the ones I want to talk about is the vacuum simulator. So if we open up that very small application, downloads pretty much instantly. So it's a great learning tool, and it's a great reminder of what we should be seeing with this simulated interactive vacuum gauge. So we can look here at normal. We're around about 20 inches of mercury. We can give it a snap throttle. This is what we'd want to see on a regular good working engine with a bit of an explanation. Now, if we go down some of the possible problems that we could have, for instance, so let's say we've got a burnt valve. It shows this sort of regular, evenly spaced downward flicking of the needle that we might get. We can still give it a snap throttle, and it shows, if we were seeing that on the gauge, we could go through here and try and determine what we may be looking at. Restricted exhaust, for instance, so I'm not going to click anything here. You'll see we're at idle, and by itself it's raised the RPM, and this is what we would see on a vacuum gauge for a blocked exhaust. We can read through here and it's going to give you a bit of an explanation. So really good for anyone who hasn't used a vacuum gauge. Definitely a great little learning tool, and for anyone who is familiar with it, it's a little bit of a refresher. But vacuum gauges, I'm sure, as we all know, a super important mechanical tool that I don't believe has lost any of its merits. Another great diagnostic tool that ties into using a vacuum gauge is the map table. So if we open this little web-based app, we just need to put in barometric pressure at your workshop. So it's 101 barometric pressure at my workshop. We can change that to whatever you like, but I'm working in kPa here. Now, if we click calculate, it's going to spit out this table that I'm then able to use as a reference in relation to my barometric pressure. So why would we need this? Well, if I'm looking at a map sensor, that's called an absolute pressure reading. So the map sensor, being an absolute pressure sensor, it uses absolute zero as its zero reference. A gauge, which you may be more familiar with, you're using a traditional vacuum or boost gauge, it's going to give you gauge pressure, which uses atmospheric pressure as its 0 point. So in my case, there's 101 kPa difference whether I'm looking at absolute pressure or whether I'm looking at gauge pressure. So why would I want this little table? Well, most of the time I'm going to be using this for freeze frame data. So if I've got a fault code that's set, we've got a map sensor, and that's going to be one of the more common sensors that's going to show up in freeze frame data, particularly if you're looking in OBD2. So if I've got a map reading at the time that the fault code's set, I can then basically use this to convert. And so let's say I would expect something around the realms of if we're at hot idle 20 inches of mercury, well, I'd want to see a map reading of 33 or so kPa. So you can see we've converted the inches of mercury and kPa there in relation to my barometric pressure. So once you've used this for a while, you start to get pretty handy with, I know when I'm looking at freeze frame now that I want to be around that 30 or so kPa of map, and that translates to my 20 inches of mercury. So if we're doing a fault code that maybe something to do with the VVT, for instance, and we're trying to determine, okay, at the point this car was setting this fault code, did I have some kind of electrical circuit problem with, say, a VVT oil control solenoid, which isn't really going to affect the running condition of the car because it's just going to go back to base timing? Or did I particularly have a mechanical issue where it really had altered the timing? There's not much in this fault code to direct me, so I'm using what I can. Now, we might be able to see the map, and the map was reading around 50 kPa. So we know that we were probably only running about 15 inches of mercury. To me, that sounds like a car where the timing was off during the fault. It might only be an intermittent thing. And so we're able to use this to basically calculate that out for us so that we can compare absolute pressure versus gauge pressure.